Hello everyone, this is Eric. Welcome to Alteryx at Lion. Today we are going to have a look at Alteryx Weekly Challenge number 213, Optimize the Flower Arrangement. Let's have a look at the background of this challenge. A florist is making 10 flower arrangements, and he likes to maximize the total number of flowers in each arrangement. Okay, so there are 7 different kinds of flowers, and then there's one kind of green, filler green. Each arrangement needs to have between 4 to 8 of the flower and between 3 to 4 filler greens. And he only has a budget of $950. How many of each flower should the florist order? Okay, let's jump back to the Alteryx. I have already prepared this workflow beforehand, but let me run this first, and then let's see what information we have been provided. Okay, so we have been provided a list of flowers from 1 to 7, and then filler greens, and the price of each. So what the florist wants is a list of, like a shopping list for each flower, how many he needs to buy to maximize the use of flowers and to meet the requirements of the budget. So today we are going to use a new tool. It's called Optimization in Prescriptive. This tool has 4 inputs, so we need to identify the information from our input file. So let me run a formula. Let me connect this. We need to define a lower boundary for the flower arrangements used. So if flower equals filler greens, then the lower boundary is 30, else is 40. And if, and give it an integer, and then the upper boundary, if flower equals filler greens, then it's 40, else 80, and if integer. We also need to create a new column called include, and I'll give it 1 as integer, and then lastly a column called type. I'll give it an integer as a string. Let me run this. Okay, so what we have done is we are expanding this column, the table, with upper limits of the each flower, and then we give a type and include. Okay, so let me use a select tool, and I'll unselect the price, and I'll keep everything else, and I'll use this optimization to connect this to O. And then I will use another select tool. This time I'll select only flower and price. I'll unselect everything else. I'll connect this to I. And then for the for B, the matrix input mode, we need to do some input. So that manual input, so we do a text input. I'll do constraint direction and right hand side. So constraint is the price, direction is small, less or equal, and then $950. I will connect this to B, and in the optimization configuration, we select specify model as matrix, linear program, GLPK as is, maximize object, yes, and then dense matrix variable in rows. It's because our flowers are in rows, so we select that option. And then we have to select this one, display field mapping for input anchor O. Variable column, this is flower. Coefficient column is include, lower boundary, upper boundary, and variable type is type. Okay, and then the output is coming out of this S label. So let me run this first. Okay, so we have 9 outputs, 470 flowers, and here is we have 470 flowers arrangement for the total flowers that he needs to buy. See, then the outputs are the same. So this is a really good tool when we are having different constraints and limitations, either upper or lower limitations. So in Lion, maybe what we can do is when we are given the list of or a certain resource, and then we want to make a decision whether we're producing beer A or beer 2 or milk A or cheese, then what maximize our revenue to meet the market demand. So we can use this kind of a tool to prepare the list of the shopping list or the products we are going to produce. So this is a really powerful one. I hope you like this video. Thank you very much. This is the end of this session. Thank you.